Hello. Yes, my name's John Perham, and I'm going to try and solve the Math 1131 Calculus tutorial problems for week 2. So anyway, let's start at the beginning. The first problem is solve the inequality x greater than or equal to 6 divided by x minus 1. Well, that both sides of that seem to be fairly well defined, except when x equals 1. Anyway, there are many ways of doing this kind of thing, and one of them is to draw a graph. So let's draw a graph of the left-hand side and right-hand side of the inequality. So let's go and get a tool for doing this out of our toolbox, and we will paste that into our solution. So the two functions, so let's the left and right hand sides can be plotted using. So let's plot that, and we can see that this is the left hand side and this is the right hand side, so it's all good, and we want the first graph to be plotted in red and the second one in blue. So let's do that. And that's the graph. Well, let's go back to look at the inequality here, and if x is greater than the right hand side, then the curve of the left hand side should lie above that of the right hand side. So let's look at the graph, and we can see that that's certainly true here. We can see that this inequality is greater than or equals to, so it's also satisfied at the point here where the two curves intersect, and we can see that the red curve, or the line, lies above the blue curve, provided x is greater than or equal to -2 and less than 1. Well, we believe that to be -2. We now have to find those 2 points, so let's do that by converting this into an equation for the endpoints, or the two intersection points. So we'll copy that equation down here, and now we'll multiply both sides by this factor here, and that will cancel there, of course, and then we'll put that over here, and then we'll move this 6 across to this side, and the result of that has to be equal to 0. Well, that's a quadratic equation, and it's pretty easy to see that that is quadratic equation can be written as x plus 2 times x minus 3 is equal to 0. Is that the case? Well, we can see that if we multiply this out, that we'll get 2 by -3, the constant, -6, and the coefficient of x will be 2 minus 3 is -1. So that's the quadratic equation, and so we can see that the endpoints of these intervals are in fact -2 and 3. So let's write down the solution to the problem. So the inequality is satisfied. So let's write that here. The inequality is satisfied if, and now we can write, we'll write that down, -2 is less than or equal to x is less than 1, and x is greater than or equal to 3. And it's not and, in fact it's or. And that's the solution to that problem. So let's close that down. So let's now go on to the next problem, which is to solve this inequality. Now this is kind of different, but let's use graphics again. So we'll get our plotting tool. Now there are various strategies. We might try and plot this, but I think the best way might be to plot the numerator and the denominator. So let's do that. So the numerator is well, in that function is called abs. X minus 1. So that's the numerator. And we can customize that for the denominator. So that's the absolute value or the numerical value of x plus 1. So that's and perhaps we should the numerator can be plotted using. Okay, so this inequality will be satisfied provided the numerator, which is the red line, lies above, or graph of the numerator lies above the graph of the denominator, which is the blue line. We can see, sorry, it lies below the, we want this to be less than 1, so this means that this should be less than this, or numerically less than this. So we can see that that occurs when in this region here, and remembering that it's a strict inequality, so we can write the inequality satisfied when x is greater than 0, which is here. So that's the solution to that problem.